Hey everyone, welcome to a new video. Now we're talking today about a brand new concept because now we're looking at taking trigonometry as we've done in the previous couple of videos past the parameters of just a simple right angle triangle. We're going to apply this now using this thing called the sine rule. So this is the sine rule that you get given in your school textbooks. We are looking at using trigonometry for non-right angle triangles. So, for example, solving problems with these unique types of triangles, which are non-right angle triangles. And what we're going to be doing in this video is investigating this formula we've got over here, and that's going to be it for this video. We're just going to be deriving this formula, seeing why it is the way that it is, and in the next video we're going to be using this to actually solve some problems, do some questions with that. So if this doesn't interest you, you can wait till the next video, but I'm going to spend a little bit of time talking about why this formula looks the way it does, because it's kind of weird, right? We've never seen something like this before. So we want a bit of a deeper look into why this is the way that it is. Now, what we're going to do in order to make sense of this, we're going to draw a non-right angle triangle, something like this. And we're going to say that, let's call this angle C, let's call this angle A, and this angle B, and we have the sides opposite to these. So we're just making this the same as kind of using the same pronumerals as this rule here. And let's actually give ourselves a bit more space here. Okay. And we want to investigate this guy over here. So, like with most things, when we are encountered with a brand new issue, we want to try to break this down and express it into what we currently know. So all we currently know about trigonometry, well, the first thing we actually learned was working with right angle triangles. This was the main kind of tricky, weird thing that we learned with trigonometry, was how to work with right angle triangles. So why don't I make this right angle triangle, this non-right angle triangle I should say, why don't I break that down somehow into something we're more comfortable with, like a right angle triangle. Now what if I drew a line from C down to the base of the triangle, this line AB, and I made it so that this line was perpendicular to AB. So it's going to make a 90-degree angle here and a 90-degree angle here. And let's say that this is now the perpendicular height of my triangle here. So we're going to call that side, or that length, H. So what we've effectively done is we've split this up into two separate right angle triangles. We have this guy over here. We have this, and we have angle, or part of angle C, and we have B here as well. So I'm not going to label in this really explicitly just yet. And we have H here. And we have broken this down over here into another right angle triangle, where I have angle B, I have a height H, and a length of A here. Okay, so this is where the sine rule and coming up with it gets a little bit sneaky. And it requires a lot of playing around, but why don't we try to, because we want to relate these things to one another, but we kind of can't just yet. But one thing that's unique to both of these triangles is this length of H. notice that h is the only thing that these two triangles have in common. So let's work around this h. Let's try to make sense of what this h actually looks like, how we can make an expression for it. So taking this triangle on the left-hand side, what we currently know about trigonometry is SOHCAHTOA, the trigonometric ratios, and how to essentially come up with how to make one of these sides the subject of our formula. So what we're going to do is we're going to say, well, what sides have we been given here? I've been given a h, which is the opposite to this angle. So imagine my theta's here, because that's the one angle we're given, this angle A. O is the opposite, B is the hypotenuse. So the trig ratio that links these two together is going to be sine. So sine of theta is going to equal to the opposite over the hypotenuse. So if we wanted to do this in terms of what we've been given here for our pronumerals, that's going to be h over b. Now, if I want to get h on its own here, I just have to solve this equation. So getting h divided by b, making this into h, I can multiply both sides by b. And I'm going to get b times sine theta equals to my perpendicular height h. I'm going to do the same thing over here. I have an angle here I'm given as b, and these sides, in relation to that, my h, my perpendicular height, is going to be my opposite side to this angle, and my side A is going to be the hypotenuse. So same thing, I'm going to set up my trig ratio. So sine of theta, because we have an opposite and a hypotenuse, that's going to equal to this. And once again, I can write sine theta equals to h over a. And same thing, I just want to get the h on its own. So it's the exact same process as the previous example. So multiplying both sides by a is going to clear the a from the right hand side and leaving me with h. And that's equaling to a sine theta on the left hand side. Okay, so now I have two different ways, two different expressions for h based on these two right angle triangles, based on the way we decomposed my original non-right angle triangle. So since these two are the same, I can therefore say that b sine theta is the same as a sine theta. Because the h's are the same and they're equal to whatever's on the other side of the equation. So we can say those other things, b sine theta and a sine theta, are equal to one another. And finally, in order to get it to look kind of like the thing we have up here, we've got the A's grouped together, we've got the B's grouped together, we've got the C's grouped together. So, I have left something out. Instead of this theta, I'm going to put the angle name here. So instead of the theta, I'm going to put A and B, angle A, angle B. So the sine of A, the sine of A, and B sine A equals to H. And the same thing over here. I'm just replacing the theta with the actual angle name that's listed there. So instead of theta, I'm going to put sine of B. I'm going to do that all the way through. And I have B sine of A equals to A sine of B. Cool. Okay, now we can focus on grouping the sine A and the A, as well as the B and the sine B. How are we going to do that? Well, from this left-hand side, let's get the sine A over to the right hand side. So I'm going to divide this whole thing by sine A. And since this is an equation, I'm doing this to both sides. So I have here B equals to A sine B over sine A. And I want to get the sine B over with the B on the left hand side. So what I'm going to do is I'm going to divide this side by sine B. That's going to kill this guy over here and bring it over to the other side. So I'm left with, finally, B over sine B is equal to A over sine A, which resembles the formula here. Now, you're probably saying, well, where's the sine C? Where's that going to come from? Well, we can deconstruct this in just a different way. So if I take my same triangle, if I copy this, paste it down the bottom here, I can decompose this right angle triangle in a number of different, this non-right angle triangle in a number of different ways. So instead of having the perpendicular height here, what if I was to, oh no, let's redraw this in. What if I drew a perpendicular height somewhere here? So I made a perpendicular line and stretched it over to there. I get a couple of new right angle triangles. So let's say I have this here and I have a length of h, my perpendicular height. Now I can break this down into two new right angle triangles. So I'm basically just in a bunch of different ways decomposing my non-right angle triangle into a series of pairs of right angle triangles. See, here I have this one here and I have this one here. Okay, so this left arrow, I'm going to do this top triangle. So that's going to be really thin one here, where I have A, H, and C, angle C down the bottom here. And this one here is going to be a similar thing. I have my angle, I have my height, I have my, sorry, I forgot a C here. I have a hypotenuse of C, and I have an angle over here of A. So I'm going to do this in the exact same way. And we're going to basically see, now I'm going to do this a bit quicker because now we're used to doing this from what we got up here. We're going to do this a little quicker. So I have sine of C equals to my opposite h over my hypotenuse, A. So h is going to equal A sine C. I'm doing the exact same thing as before. And here, sine, from the perspective of my angle A, is going to be my opposite h over my hypotenuse C. So I can say, therefore, h equals to C sine A. And these two are equal now, because they're both equal to h. So A sine of C is going to be equal to C sine of A. And rearranging the equations again, I'm going to eventually get to A over sine A equals to C over sine C. You guys can take your time with this, have a go at this if you'd like. But now we have C over sine C is equal to A over sine A. Now if C over sine C is equal to A over sine A, then it's also going to be equal to b over sine b, because that's equal to a over sine a. And hence, we have our formula, finally. So we have shown, by breaking this up in a number of different ways. Now, you didn't have to necessarily do it this way. One final way you could have done it, to show the exact same thing, was you could have broken it up like this. And you can relate these two right angle triangles again. So there's 3 different ways we can break up this non-right angle triangle into pairs of right angle triangles, and using the same thing. So we can finally say, therefore, a over sine of a equals to b over sine of b, which equals to c over the sine of c. So that brings us to the end of the video today. This is how the formula works and why it works in the way it does. And in the next video, we're going to look at practically applying this to some questions. So thank you so much for joining me today, and I'll see you in the next video.